number 2, here we go, 6.6, functions, function operations. So we have worked with functions previously in the year. So I hope this video helps those of you at home or those of you who might need just a little additional instruction. Okay, so a little review here. A relation is a set of ordered pairs. All right, ordered pairs are just, points. So this right here is a relation. A relationship between these numbers. Okay, so basically -3 is an input and it produces 5, an output. All right, 0 is an input and it produces -7, an output. 4 is an input, produces +5 as an output. There's a negative up there, there's not. 5 and 6 is an input, produces -9. Okay, so the domain is a vocabulary word we use. This describes all the x values or all the inputs. Okay, so the domain here is -3, 0, 4, and 6, and put these in order, in sequential order. And then the range is the set of all y values or outputs. Okay, so the range here is -9, -7, and then 5. You only want to list that once. Only list that once. Okay. So this next piece here says, let's take a relation and turn it into a function. It is special in the fact that each input or x value corresponds to exactly one output or y value. So what does this exactly one mean? It's kind of easier to explain what is not a function versus what is. So -3 only goes to 5, 0 only goes to -7, 4 only goes to 5, and 6 only goes to -9. Okay, and so I could even have 4 go to this 5 up here. Just list it once. So the -3 and the 4 both go to 5, and that's okay. I call this converging. So because -3 does not branch out, it only goes to 5. 4 does not branch out, it only goes to 5. So that's exactly 1. Even though they go to the same, individually they go to exactly 1. So this is a function. What it would not be a function is if -3 was paired with 5, and then it decided to be paired with, 2. That's not a function. And the easiest analogy I can give you is grades. If I had a 90 and it was an A, it's fine. And a 92 is an A, that's fine. That's functional. But if a 90 was an A for one student and a B for one student, this would not be a function. Okay, and so I call this diverging. This is converging, which is okay, but branching out or diverging is not a function. Okay, so function notation is f parentheses x. This reads f of x. And it just means plug x into f at x. So x is the input and f of x is the output. So that means I can say that f of x is the same thing as y. And that will greatly simplify sometimes when you're confused as to what to do on a problem. If you just think of f of x as nothing other than y, then that can kind of help you. All right, so let's just do some quick problems here. This says to plug -3 into k at x. So there's k. All right, and k is x, so -3 over 2 times x, so -3 plus 5. So this is just -3 over -6 plus 5. So this is just -3 over, not a lot of room here, -1, which is just 3. Easy. F of 3t, plug 3t into f at x. So f of 3t equals 5 minus 3. So instead of x, I'm writing 3t. So that is equal to 5 minus 9t, and that's all that I can do with that problem. They're not like terms, so they can't be combined. Plug 5x into g at x. So not at the negative, just x. Okay, so x is squared. So that's where you do your plug-in, just on x. I'm going to do a parentheses here because 5x is two terms. Or, sorry, not two terms. Two, a coefficient and a variable. It's two things, not two terms. All right, so this negative does not get squared. Only the parenthesis gets squared. So the negative's just chilling out in front of the problem, waiting. And you get 25x squared, waiting to be considered. So you get negative 25x squared. All right. Oh, I forgot this plus 6x. Sorry, plus 6x. You guys are probably like, oh, there's a 6x. Don't forget about the 6x, Mrs. Mullet. All right, so this is then 6x, so replace that with this 5x also. Sorry, so I need 5x to go in right there, and I need 5x to go in right there for this particular problem. All right, so this is negative, waiting to be considered until I square everything, 25x squared, and then it attaches itself, and then this is plus 30x. All right, so negative 25x squared plus 30x. Okay, f of a minus f of b. My f function is here, so this says to plug a into f at x. This says to plug b into f at x. Okay, let's do that. So 5 minus 3a minus, and it's two terms, so I'm going to protect it with parentheses, 5 minus 3b. Okay, so I just 5 minus 3a minus 5 minus 3b. And so since I'm minusing two terms, I need that parenthesis. So this becomes 5 minus 3a minus 5 excuse me, plus 3b. So the 5's cancel, and this is just negative 3a plus 3b. All right, f of x plus h. Okay, so plug x plus h into f at x. I'll just save myself some room and just write equals and go for it. So 5 minus 3x. Instead of x, I'll write x plus h. And distributive property. And that's all I can do here. Those are not like terms. Okay, g at x plus 3. Let's relate. Let's erase so I can see what's going on here. Okay, so negative x. Now, instead of x, we'll do x plus 3. Quantity squared. Won't forget about my 6 this time. 6x plus 3. All right. We're going to have to FOIL. Okay. And this will just be plus 6x plus 18. I have to leave my negative, hanging out in front until I'm ready to consider it. X squared, that's f. OI will be plus 6x, and last will be 9. Negative x squared minus 6x minus 9 plus 6x plus 18. Those cancel, and I think I'm done here with negative x squared plus 9. Negative x squared plus 9. All right, last one. Let's plug x plus h into k. X plus h, so I'm just plugging it right there, over 2 times, parentheses, x plus h, plus 5. 2x plus 2h, that's the distributive property. All right. So, there you go. That's the first part of our 6.6. Let's move on to domain restrictions. Okay, what are domain restrictions? They basically mean what x is not allowed to be. Okay, so your domain is what x is. Your domain restriction is like what x is not allowed to be. And there's two things you have to consider until we get to logarithms. There's two things you have to consider. We can't have a negative under the radical. What can't you have under the radical? Negative because it's imaginary. So if you have root x, x needs to be positive and 0 is okay. Whatever's under the radical needs to be positive or 0. And what can't you have in a fraction? A 0, sorry, not a negative, a 0 in the denominator. So if you have 1 over x, x cannot be 0. Those are your domain restrictions. And we talk about that a lot in class, so hopefully this is pretty straightforward. So find the domain for the functions algebraically. So basically, x minus 3 cannot be negative. It can't equal a negative. So how do I write that mathematically? X minus 3 must be equal to 0 or positive. So you just write x minus 3 greater than or equal to 0. Solve your little inequality. Okay? And that is your domain. I think Math Excel is going to do x such that x is, what am I doing? Add 3, add 3. Add 3, add 3. There we go. X is greater than or equal to 3. Okay, add 3, add 3. This is like my 5th video today, so I'm getting a little delirious. All right, so next piece here is a fraction. So x plus 3 cannot equal 0. X cannot equal 3. This is a domain restriction. This is a domain restriction. So, you know, what is the domain? The domain is what x can be. X, that just means kind of x, you know, colon, what can it be? X can be all real numbers except 3. I can plug anything into here except for 3. 3 doesn't work because you get 1 over 0. Undefined. So your domain here is I can plug anything in the world I want to here, and I just can't have 3. Otherwise we're good. So just say x is all real numbers. X can't be 3. All real numbers. X can't be 3. All right, this next one, under the radical, I need it to be greater than or equal to 0. So x needs to be greater than or equal to negative 5 over 2. Put an x colon in front, and there is your domain. Okay? Here, 2x plus 5 is in the denominator. That can't have b0. You can't have a denominator. That's equal to 0, so x can't be negative 5 over 2. It would make that denominator 0. So how do I write my domain here? X is all reals. Just even write it that simply. But x can't equal negative 5 over 2. All right, and the last one here. This, do I have a denominator? No. Do I have a radical? No. This is all real numbers. You can plug anything you want to into that. You're not going to get a 0 in the denominator. There's not one. You're not going to get a negative under the root because there's not one. All right. Onward and upward. Next page, Algebra 2. Operations. So let's add, subtract, multiply, and divide. Easy. This works just like polynomials. Okay? So when you're asked to add f plus g, you're just doing f plus g of x. So let's write down f. Let's write down g and add them. E, z. That's f. And that's g. Okay, so 4x squared plus 11x minus 11. Just like polynomials, it's just written in terms of functions. Okay, h minus f. So I have to minus off f here. So f consists of 3 terms. So I want that in parentheses. X plus 3 minus 4x squared minus 6x plus 9. So you're distributing the negative. You're really distributing a -1, but I just say distributing a negative. So make sure with minus you put the second one in parentheses so you don't miss the sign. Let's clean it up. Negative, going descending order, 4x squared minus 5x plus 12. All right. G times h, so g is here, and x plus 3 is here. So this is just g, this is just h, and we're going to do our favorite thing, FOIL, x squared plus 15x minus 2x minus 6, 5x squared plus 13x minus 6. Okay, divide, add, subtract, multiply, divide. G of x is 5x minus 2 over x minus 3, and I am done. Okay, does say to state any domain restrictions. Well, I don't have any denominators until I get to D, and I don't have any radicals, so I don't even have to think about this unless I have a denominator or a radical. Well, now I have a denominator, so here x minus 3 cannot equal 0. And what would make that happen if x were equal to 3? So the domain here is basically x can be all reals, but x can't equal 3. And that was positive, my bad. So that's positive, so that's negative, so that's negative. Okay, sorry I missed that sign, but just didn't transfer that correctly. That was positive, so that's negative. All right, composition of functions, a new operation. So operations here means plus, minus, times, and divide. And there's a new one called the composition. This symbol is this little degree symbol looking through. Compositions of functions. All right, this is when the output of one function becomes the input of another. And you might see f, that degree symbol, but it's here. It's not a multiplication symbol. It's open like a degree symbol, and it's definitely open. You may see that with the x behind it, or you may see f of g of x. Okay, so this just means plug g into f at x. Plug the function g into the function f at x. All right, so this is kind of a visual, and that's for what I wrote here. So this says let f of x be 3x minus 2, and this is g of x equal x squared. So it says using function machine, start with an input of 2 into f. Okay, so if f is the first one, then this one here, I wrote this with f of g. This one is asking you to do g of f. So it's asking you to plug f into g. All right, and then this one has a value. So this one has a value. So actually, let's save this function machine until I go over here. Let's do this one first, okay? So this just says do this one first. So you do the one more to the right first. So h of 3 is 5 plug 3 into h at x. This is 15 minus 2. This is 13. So h of 3 is 13. So I've got g of h of 3. So I know what this is. So this is asking me then to do g of 13. So the output of h becomes the input of g. So now I'm going to go to g and do my computer went down. There we go. We're back. I don't know if you guys went dark there, but I did. So this is g of 13. So now I'm going to go to my g function and do g of 13. Okay, so that is 4 times 13 squared, 4 times 169, and 4 times 169 is 676. All right? So you're plugging that value of h at 3 into g. So this, since I'm plugging this 2 into f over here on this function machine, so this is asking us to do this f of 2 first. So this is a g of f, okay? Whereas I defined it over here as f of g because it's more standard to just have them in alphabetical order. Whatever, it doesn't matter. You can any problem can be in any order. So f of 2 then. So if I plug 2 into this function machine, it drops into this machine. The machine does its business. 3 times 2 is 6 minus 2, which is 4. Okay, that's the output. And then 4 drops into the G machine. The G machine is squared, and that's 16. Okay? And so this is f of 2 was 4, and then we did G of 4, which was 16. All right? So this was G of f of 2. That's another way you might see it written, or the dot. All right, so if we went the other way, if we had put negative 3 into the function machine first, g of f of negative 3, we would have gotten f of negative 3, which is 3 times negative 3 minus 2. That's negative 11. And then we would have done g of negative 11 and just done a negative 11 squared for 121. All right, and that's what we just did over here. So these next two here don't have a value. There's no number here. There's no number here, just an x. So in these two, your answer will be, it's kind of it's an equation. It's a new function, but I'll just say equation. So I'm just taking f and plug it into h at x. Okay, so I am just taking the f function and putting f right there. Okay, and that's f of x. So this will equal 5 times the function at f of x minus 2. Well, what is the function? It's two terms, so I'll use parentheses. So it's 10x when I distribute. It is 10x plus 13. And you can't get a number there because you don't have anything to plug in. Same thing here. I'm going to plug f into g. Okay? I'm going to plug f into g. So I'm going to start with g, and g is 4 times x squared. So I'm going to plug f of x in for x. So I'm plugging the function f into g at x. All right, and so this is 4, and the f function is 2x plus 3 squared. All right, so that would be your answer. If you are asked to simplify it, you would want to, our favorite FOIL, we love foiling, leave the 4 alone. That is 4x squared plus, here you're going to get 6x and 6x, which is 12x plus 9. For a final, can you guys still see? 16x squared plus 48x plus 36. Speedy there, I know, because you can rewind and pause. All right, next question.